Okay, for in this example we will see on how to calculate the y parameters with a given circuit which is have dependent source. So here we say we have a dependent current source. So when we have this kind of question, it's better to start with the conventional method. And maybe the alternative method might be difficult. Anyway, we try with the conventional method first. So as I teach you before, the conventional method, you will have to eliminate one of the, let's say you want to find this parameter y1, and let's say you want to calculate this parameter y11 and y21. Okay, so you have to, and in that case you have to turn off this power source V2. You have to turn off. In when you're calculating the y parameter, when you want to implement a source, it should be like a current source, and when you want to turn off the V, it should be short circuit. So this is actually port 2, this is port 1. So in this case I have to turn off V2 over here. If I want to turn off V2, I need to short circuit it, then the V2 will be 0. But we still will have the I2 we will have it, just that V2 will be 0. And I need to create a current source here. I need to create a current source here. For the sake of better understanding, just label it like I1, because it's actually referred to the I1, and this current source dependent on this I1, so we label it as I1. Okay, and when you want to analyze, you can use a lot of methods, but choose the best and easier method. Like if I use like a mesh analysis, I will have like a 3 loops. Okay, 3 equation will be there. But if you use like a nodal analysis, you only will have like 1 equation. You see, nodal means if I choose this node to be the node in the nodal analysis, only one node, because this one actually directly to the ground. Okay, I have to label V1 we still have here across the current source. So no it's any specific voltage drop here. So in this case, I can choose to have the nodal analysis. So just label this node as A. So in nodal analysis, the current entering the node equals to current coming out from the node. So let's say I label this current Ix and Iy. This is going out of the node, this is coming inside the node. So the equation for this node A, at node A, at node A, I have I1, the current actually going inside, I1 equals to 2I1 coming out from the node. See the above here we have 2I1 plus Ix plus Iy. Okay. Okay, then the next step is to shows what is actually Ix and Iy, define Ix and Iy. Okay, if this is actually short circuit, here actually we have like a this point also ground, this is actually ground, 0 value. Okay, so the current drop here VA over for Iy. Here also ground, VA over 2 Ix, actually VA over 2. Okay, only the I1 we have to be careful, where I1 is, you need to create the equation for I1 where I1 is V1, because we have a voltage drop here, V1 minus VA over 8 is still I1. Okay, so before we I just write what is I1. So I1 equals to V1 minus VA over 8I1 here, we like that can be defined like this, and we simplify the equation. So here negative I1, if I bring the 2I1 here, will become negative I1 minus 2I1 negative I1. Ix is VA over 2 and Iy is VA over 4. And now you look at this equation. So we want to get y11 and y21. So once I eliminate this one, all this actually becomes 0. So I1 is I1 over V1. If I bring the V1 here over I1, I will have y11, and I2 over V1 is y21. So to get the parameter of y11, I should have only I1 and V1, and we have like a VA here, right? We have like a VA here. So obviously we cannot have a VA here to get the y11, right? But here you see I can derive the VA in such a way that it is in terms of I1 and V1. So if I substitute VA here, then I will have everything in terms of I1 and V1, then I can get this y11 parameter. Okay, so VA, this can be defined as, from here you see VA can be defined as 8I1 minus V1 is negative VA. In other words, you can write VA as V1 minus 8I1, right? Okay, you can write like this. Then I will substitute the VA here, but before that I just want to make the equation simply, in a better form first. Yeah, no need actually. You just can add this, both of them together. This will produce 3 over 4 VA. Okay, these two actually produce 3 over 4 VA. So I will rewrite the equation I1 equals to 3 over 4 VA. Okay, what is VA? VA is V1 minus 8I1 this is negative I1, and I can V1 equals to 6I1, and I bring the negative 6 here, it becomes positive. 6 minus I1 is 5I1 equals to 3 over 4 V1. Okay, then I1 over V1, I1 over V1, I bring the V here and then I bring the 5 here. It becomes like 3 over 20 as the unit actually S. So y11, we already get the y11. Okay, that's all how to get for the V1. So the whole idea is you just proceed with solving the circuit. Okay, and as you goes on, as you you're solving, you will see that okay, you always stick with I need to get everything in terms of I1 and V1, and you need to modify the equation so that everything will be in terms of I1 and V1. So this y11 done. Now y21. Y21 means I need to have the current over here. I have to describe the equation based on this current here. Okay, for this node we already solved the I1 V1, and I'm planning to go to look at this node now, second node here, because then only I can describe the equation in terms of what is that, I2. Okay, so let's say we call it as a B, this node. So at node B, okay, use different color. At node B, I can write the equation. So this equation actually IY here, and I2 in this direction, and I2 I1 actually in this direction, all of them actually entering the node. If you see, all of them actually entering the node, so everything should be in one-sided equation where IY plus 2I1 plus I2, write everything in capital letter, equals to 0. Okay, so IY is the V here actually 0, VB actually 0 because no voltage drop here. So this will be IY will be VA over 4. No need to write VB, because minus VB, because VB actually 0. I'm just choosing the node because I want to write the equation. Plus 2I1 plus I2 equals to 0. And what is VA? VA is just now where we got in this case. VA we already found just now, right? VA is V1 minus 8I1. Okay, and if I do want to have the 4, I just multiply everything with 4 first. So VA plus 8I1 plus 4I2 equals to 0. Okay, now I substitute the VA. VA is V1 minus 8I1. I already substitute here. Then just follow the previous equation. 8I1 4I2 equals to 0. And you can see that I can cancel the I1, 8I1, negative 8I1 plus 8I1, left with V1 plus 4I2 equals to 0. Okay, then I can write in a way that 4I2 equals to negative V1 and I2 over V1 is negative 1 over 4s, and this is actually y2 1. So we managed to get the the first two parameters, y11 and y21. Okay, so this is done. Next we go to the second equation, where we want to get the y12 and y22. Okay, we redraw the circuit, we observe this equation again. Okay, so I need to cancel V1 and I need to get the Y1 and Y12 and Y22. So cancelling V1 means I need to short circuit at this side. I will still have the I1, and only the V1 actually going to be 0, and in this side I will put a current source I2, and I'm going to have the V2 also here. Okay, so we can start to have same like that. Before we have like first we start with node A, so I can write the equation here. Current entering the node equals to current coming out from the node Ix, Iy. So I1 equals to Ix plus Iy plus 2I1. So Ix x is VA over 2, this is VA over 4 plus 2I1, and this is actually I1. I can bring the I1 this side, same like before, where negative I1 equals to 3 over 4 BA. And now we check back what is actually I1. It won't be the same because here we don't have like a voltage drop. So I1 is, so this is actually 0, right? 0 minus VA, 0 minus VA over 8 is actually I1. So I1 is negative VA over 8. So VA is what? VA is, I can bring the 8I1 directly. VA is negative 8I1. So I'll substitute here, negative 8I1, negative I1 equals to 3 over 4, negative 8I1. Not something wrong. I need to describe everything in terms of I1 and I1 and V2. I did a mistake here, I think. Let me check. Because we no need to describe everything on the V. Oh yeah, the I2s. IY actually wrong. Sorry for that, because V2 is still missing. Okay. This part actually wrong. Let me erase this as well. Okay, so here, because I followed the previous equation very quickly. So IY supposed to be this is actually V2, the voltage drop here actually V2. IY is VA minus V2 over 4 plus 2I1. Sorry for the mistake here. So I bring this side, negative I1 VA over 2 plus VA over 4 minus V2 over 4. Now I can make it like a single equation. 3 over 4 VA, okay, negative I1 minus V2 over 4. So if just I want to bring, because this can be factorized outright the 4 1 over 4, I can bring this side. Negative 4I1 equals to 3VA minus V2. Okay, the VA I can substitute now. This is 8I1 minus V2 negative 4I1. So this is 24. 24 minus 4 is actually 20 I1 negative V2. So I1 over V2 is negative 1 over 20 as done. Okay, so this is actually Y12. You already find the Y12. Okay, then I want to get the Y22. I cannot use the same equation. I use this second equation where I choose this node. Okay, this node, we can label it as a 2 because voltage, this actually we have like a V2 here. So here when I write the equation, I write the current equation first. It's different color. IY plus 2I1 equals to IY. This is I2 plus I2 equals to 0. Okay. and Iy, I can write in a way that VA, same like here, VA minus V2 over 4 plus 2I1 and I2 have to keep it because we will use everything in terms of I2 later. So I don't want to have the VA same like that before. Okay, but before that I just want to multiply with 4 because I don't want to see the 4 here bottom. So VA minus V2 plus 8I1 plus 4I2 equals to 0. And now I can substitute the VA equals to negative 8I1, correct or not? So negative 8I1 minus V2 plus 8I1 plus 4I2 equals to 0. So these two be cancelled, remaining negative V2 and 4I2. 4I2 equals to V2, okay, and I2 over V2 equals to 1 over 4, which is Y22. Okay, and the unit is actually S, admittance. Okay, so I hope you understand and you can go through the video many times if you cannot get any idea here, or you can still contact me, ask me any question regarding this analysis. So thanks for listening, hope you enjoy the class.